Hello students, next topic is name reactions in organic chemistry. First part contain Sandmeyers reaction, Gatterman reaction, Balz Schimann reaction, Finkelstein reaction and Schwarz reaction. Before going to the topic, please subscribe my channel, press the bell icon for notifications, like, share among your friends and comment. Dear students, welcome to my channel. Here I am giving a series of name reactions in organic chemistry. Nearly 30 name reactions study at the secondary level. So I am explaining into different part 1 to part 5. In part 1 there are 5 reactions we can study. The first one is Sandmeyers reaction, the next is Gatterman reaction, next Balz Schimann, Finkelstein and Swarts reaction. We can see each reactions in detail. Sandmeyers reaction was discovered in the year 1884 by Traugott Sandmeyer. It is a type of substitution reaction, that is radical nucleophilic aromatic substitution used in the production of aryl halides from aryl diazonium salt. Copper salt like chloride, bromide or iodide ions are used as catalysts in this reaction. In Sandmeyers reaction, transformations on benzene occur as hydroxylation, trifluoromethylation, cyanation and halogenation. When a primary aromatic amine dissolved or suspended in cold aqueous mineral acid is treated with sodium nitrite, a diazonium salt is formed. Mixing the solution of freshly prepared diazonium salt with cuprous chloride or cuprous bromide result in the replacement of the diazonium group by chloride ion or bromide ion. Here aniline undergo Sandmeyers reaction and form benzene diazonium chloride, which undergo reaction with the copper chloride, bromide or cyanide and form chlorobenzene, bromobenzene and cyanobenzene. The mechanism of Sandmeyers reaction include a transfer of a single electron from the copper to the diazonium result in the formation of a non-participating diazo radical as well as copper to halide. A molecule of nitrogen gas is then released by the diazo radical to give aryl radical, which then react with the copper to halide to restore the catalyst, that is copper 1 halide. The end product is an aryl halide. Importance: Sandmeyers reaction is used to generate substitution pattern that are sometimes not possible to achieve by direct substitution. Sandmeyers reaction has wide synthetic applicability and is complementary to electrophilic aromatic substitution. Uses of Sandmeyers reaction. Sandmeyers reaction is used in hydroxylation to convert aryl amine to phenol, leading to the formation of an aryl diazonium salt. To create aryl compound during the process of trifluoromethylation, unique chemical properties with a wide variety of practical applications. Used for the formation of benzonitrile through the process of cyanation. The reaction is also found during the synthesis of neoamphetamine, a chemical compound that target topoisomerase 2 as an anti-cancer drug. To create aryl halides, some of the solvents used in this process are diiodomethane to synthesize aryl iodides, bromoform to synthesize aryl bromides, and chloroform to synthesize aryl chlorides. Next reaction is Gatterman reaction. In this reaction, chlorine or bromine can be introduced in the benzene ring by treating the benzene diazonium salt solution with corresponding halogen acid in the presence of copper powder. To obtain chlorobenzene, benzene diazonium chloride is treated with copper and HCl. And to obtain bromobenzene, benzene diazonium chloride is treated with the copper and hydrogen bromide respectively. Aromatic compounds are formulated by a mixture of hydrogen cyanide and hydrochloric acid in the presence of a Lewis acid catalyst such as aluminum chloride. What is formylation? It is a process where the formyl group, that is CH double bond O, is attached to the compound. When we examine the reaction mechanism of Gatterman reaction, there are 4 steps involved. First step is formation of foaminochloride. Second step, formation of electrophile. Third, attack of electrophile on benzene ring. And the fourth and final step is hydrolysis of benzylamine into benzaldehyde. Applications. Gatterman reaction is used in making aromatic halides such as chlorobenzene and bromobenzene. It is used in making aromatic aldehydes such as benzaldehyde. Reaction products are used in various fields such as pharmaceuticals, medicinal and agriculture. Next is Balz Schimann reaction. The reaction is named after the German chemists Gunther Schimann and Gunther Balz, who reported the reaction in 1927. This reaction is a chemical reaction in which a primary aromatic amine is transformed into an aryl fluoride via disonium tetrafluoroborate intermediate. The primary reactants are arylamines, nitrous acid and fluoroboric acid. The process involves conversion of aryl amines to aryl fluorides via diazotization and subsequent thermal decomposition of the derived tetrafluoroborates or hexafluorophosphates. The decomposition may also be induced photochemically. The reaction is shown in this equation. The mechanism of Balz Schimann reaction is thought to proceed via an SN1 reaction mechanism. Reactivity trends have been unpredictable. Aromatic amines undergo diazotization under the influence of nitrous acid. Fluoroboric acid is added to give rise to corresponding aryl diazonium salt. This aryl diazonium salt is subjected to heat to undergo thermal decomposition and give the aryl fluoride along with the nitrogen gas and boron trifluoride. See here, benzene disonium tetrafluoride converts into fluorobenzene. Thus, aryl fluorides can be easily prepared by the Balz Schimann reaction. It proves difficult to prepare aryl fluoride by the direct fluorination of aromatic hydrocarbons due to the violent nature of the reaction and the difficulty to control the reaction, making the Balz Schimann method the preferred way to get aryl fluorides. It is also the preferred way for some derivatives of fluorobenzene, fluorobenzoic acid for example. However, the large-scale thermal decomposition of these disonium salts can lead to explosions. Next reaction is Finkelstein reaction, named after German chemist Hans Finkelstein, used in the preparation of haloalkanes or alkyl halides. It is a substitution nucleophilic bimolecular halogen exchange reaction, that is SN2. It is an equilibrium reaction if carried out without solvent. Reaction completion depends on differential solubility of halide salt in the polar aprotic solvent such as acetone. See, this is the example, the treatment of a primary alkyl halide with an alkali metal iodide, that is potassium iodide, that lead to replacement of the halogen via SN2 reaction with the iodine. Here conversion of alkyl halide into substituted alkyl halide occurs. Here are some examples for Finkelstein reaction. Ethyl chloride plus sodium iodide gives ethyl iodide and sodium chloride. Benzyl chloride react with sodium iodide form benzyl iodide, and 3-chloro-1-propanol react with sodium iodide form 3-iodo-1-propanol. The success of this reaction depends on the below conditions: nucleophilicity, nature of group, carbon-halogen bond, alkyl halide reactivity. Next reaction is Swarts reaction, reported by Frederick Jean Edmund Schwarz in 1892, used to get alkyl fluorides from alkyl chlorides or alkyl bromides. This is done by heating of the alkyl chloride or bromide in the presence of the fluoride of some heavy metals, that is silver fluoride or mercurous fluoride. The reaction will proceed if sodium fluoride or potassium fluoride is used, but the resulting yield will be significantly lower. In Schwarz fluorination, chlorine is most commonly replaced by fluorine in organic compounds with the help of antimony trifluoride in the presence of antimony salt, where its oxidation state is +5. See, antimony fluoride is represented by SbF3 and antimony chloride is SbCl5. When we examine the mechanism of Swarts reaction, the metal fluorine bond is broken and a new bond is formed between carbon and fluorine. The displaced chlorine or bromine atom now bond with the metal. The mixture of antimony trifluoride and chlorine is referred to as Swarts reagent. Swarts rule states that post-fluorination, the fluoride formed will always have a lower boiling point than the corresponding chloride. Chlorinated hydrocarbons can also be reacted with metallic fluorides to give hydrocarbons with chlorine and fluorine attached. These are some of the examples. Dear students, I hope you could understand the first 5 reactions in organic chemistry. Remaining reactions we can study in the next class. Dear friends, thank you for watching. Don't forget to leave a like and please subscribe my channel.